I wanted to introduce Greg, I guess, by sharing a little bit of my history with Greg. There's a lot of people on this call that are ex-JCI employees, or maybe they're still JCI employees that have known Greg for maybe decades or a decade. And my experience, well, was this. I started, geez, in 1995, I believe it was.
I was before that, I think was 3 or 4.
Well, yeah, I started a long time.
Yeah.
And it was right after I started, we had this really terrible M&V software back then. It was called CAR, which was really kind of dumb. And I mean, it was better than, it tried to do weather normalization, but for, some of you guys from the old days of JCI, you probably are shaking your heads now. When you compare it to metrics and just the better methods. And by the way, just so you know, I'm not taking, any credit for metrics. JCI designed that software, by the way. That was a JCI design. Anyway, so metrics first started coming out, and they had a whole bunch of us that were testing the software, and I think I was one of them. And found a lot of us found, as with any software, there was a lot of bugs to start with, and I found a lot. And Greg was he was really pushing metrics, at least that's what I thought. And he's a proponent for it, and it's a good thing he was, because it turned out pretty good. But I kept, just bashing the software, and I just saw Greg as like the enemy. That's how I saw Greg. He was the enemy, and he was always, saying things, and I disagreed with him, and I'd always tell him he was wrong, even though he'd been in the business, for 20 years already, probably. But anyway, we didn't have a good start. At least I didn't have a good start with him. I think he was a lot more patient with me. After I left JCI many years later, we reconnected, and he forgave me for everything. I don't know if he ever felt slighted, but I was probably slighting him. And yeah, great. So Greg Kurpiel has been like a mentor for JCI M&V people, for I don't know how long, because I just know in my experience, at least 10 years, and he'll tell you, because he's going to give you a little bit of his history in a minute. And he trained a lot of us, and maybe 100 or more of us in M&V basics. And anyone who was, in the old days, it was just Johnson, Siemens, and Honeywell, and a bunch of little companies. And anyone who really didn't go through Johnson really, and didn't have Greg as a tutor, really missed something, because Greg taught us so much. And a lot of some of what he taught us, we're going to go over in this next hour. And I guess I should stop so we can actually go over it. But he had a totally different attitude towards M&V than people have today. And you'll find that out. So I'll leave that that's it for my intro. Greg's going to actually give you a bit of his history, and let's just take it from there. You're up, Greg.
Okay. Could you go ahead and give me control? There it is. Show my screen. Okay, let's move over here. Okay, again, I'm Greg Kurpiel. Was with JCI for about 25 years, a little over 25 years. And yeah, John was right. John did not like the metrics software, to say the least. And he was such a pain in the butt to SRC, was it? That they called me and said, we need someone to help out and debug these things. John is our biggest, pain. He's finding all these things, and he's complaining about this and that. And I said, well, hire him. Okay. And they went ahead and to offer it, and then they hired John. And then after John was on the other side of the fence, he kind of knew what it was about, and he took metrics and made it what it is now. So, John, being part of SRC and dealing with all of that, we wouldn't have metrics as it stands now. And actually, in 1994 is when we met And then we went out for bids in 1995 to create a software which became Metrics. We had 4 or 5 groups of engineers going after the bid, because as JCI, we said we would buy like $365,000, I think. Oh, no, 365 copies of Metrics once it was developed. So that was in the contract. Anyway, a little bit about me. I come from an operational point of view. I don't come from an engineering point of view, but I do use the engineering, but I'm more on the operational side, and I rely on the engineering people who are professional engineers to do the engineering. Okay, but it has to be balanced with operations. If you just do operations, you're going to fall short. If you just do plain engineering, you'll fall short, as some of the projects we'll talk about maybe in this next hour. So, just to give you a little background, where I came from. When I started out, I was welding at 12 with my dad because he had a weld shop, and he was a contractor. And then I worked for 2 years for Shedd Aquarium in Chicago, and that's where I learned some of the things from the old timers, because I was young. I was like what John was, and I'm going, these 50, 60, 70-year-olds, what do they know? And they wouldn't tell me either. Okay, one thing they did, they would always read the utility meters every shift. And I'm going, why are they doing that? They wouldn't tell me. They were doing that to figure out if there was anything wrong in the building. But then I decided I didn't like Chicago, so I went out to California to do deep sea ocean mining research. I wouldn't go out to sea. I got a job at Kennecott and spent 4 years doing deep sea ocean mining research. Environmentally, it was terrible. I'm glad it never happened. So that closed down. And after that, I went into hospital administration. Ended up, I built 2 hospitals, and I managed 4 hospitals. Some of them I had multiple departments. Some of them I only had 1. But being able to manage a hospital, and this is where I really got into energy management, thinking how does a building operate? And the health of the building is really the utility consumption. Okay, you can have a healthy building, and this could be a hospital or office building or whatever. But you can have a healthy building or unhealthy building. But you can have unhealthy building by using too much energy for the given area that you're in of the country, or you can have a very unhealthy environmental building. So you have indoor air quality issues when a building is not using enough energy. Okay, so if your base for a given area is 38 kWh per square foot, and you're using 50 kWh per square foot, our goal as energy engineers or wherever is to find out where that excess energy is going. Okay, yeah, they may have an inefficient chiller, but the chiller really isn't using the energy. It is the consumers, the air handlers, something after the chiller that's really using it. So if you have a chiller that's 1 kW per ton, and you can reduce it to a half kW per ton, and you're using a lot of energy out in the air handlers, yeah, you're going to save a lot of money. Okay, but you're still wasting a lot of energy, you have to look and figure out where the consumers are that's dragging that chiller to use so much energy. So that is the mindset that I had, and I still have, on how to figure out where the energy's going. So by having a hospital and being able to control it, I could pin certain strategies to see if they were working or not. So a lot of these strategies I developed before I was with JCI. So I came into JCI with a number of facilities that already benchmarked on a high level, at a higher level. And I also came in with strategies and knowing where efficient buildings are supposed to be. So the first hospital
Wait, Greg,
yeah.
so you're saying, so you came to JCI and you already had all these benchmarks. Where did you get these?
I had a lot. Well, on the third and fourth hospital, I was working for AMI Hospital Corporation. AMI had, at that time, I don't know, 75, 100 hospitals
I got it.
within their network all over the world. You know, Saudi Arabia, England, Canada, US. And so I made myself a pain by asking for utility information. Actually, AMI offered me a job to go to the main office in Beverly Hills. And I'm going, I don't want to live in Beverly Hills. It's too expensive, you know, and they weren't paying me enough money to do that. But so I did out when I was working in the field, and they supplied the information, and I started analyzing it, and we were installing anovers. And so I started programming strategies in other hospitals besides my own to save energy. So I kind of got known through AMI for energy management, and also I wrote a lot of preventive maintenance manuals and procedures, I should say, and quality assurance procedures with AMI. So besides operating and constructing the hospitals, you know, I get kind of bored with that after a while, and I needed something else to do. So that's why I also developed a preventive maintenance program in my spare time, which I sold around the United States at one time. But, you know, to answer your question, John.
Yes, absolutely.
Okay, good. Yeah, I was kind of lucky. The first hospital I was in, everything was broken. Nothing was working. And so no matter what I did, I couldn't break anything. So I learned a lot there. Okay. And then in the second hospital, which was a 500 bed hospital, 2 blocks long, one of the main things is I installed the energy management system. That's when I kind of got my feet wet in that. And then when I was with AMI, the third and fourth hospital, that's when I really dove down into energy management, benchmarking, and figuring out how a building operates. JCI came to the fourth hospital, wanted to do a PC project with me. I said, oh yeah, that's fine. And this was, some of you might know Randy Lewis, who's retired now, but he came over and I said, yeah, that's fine. So he brought in some engineers and I gave him all my utility information, my benchmarking, my, you know, everything. And they came over and said, well, you know what? We really can't save you anything much. We can do a few things, but it won't pay off. And you have all this information and stuff. We have another hospital here that we sold a shared savings project on, and we're only saving about $15,000 a month, and we need, I think it was $28,000 a month to make the shared savings work. And would you want to join JCI? And I said, well, yeah, because I'm bored with this. And so it took them 6 months of losing money before they hired me. So they were doing like $10,000-15,000 a month. I went in there, and coming from the operational standpoint, I kind of benchmarked and going around. They're using way too much kWh, and they're using a lot of gas too. So I went in there and I met with the chief engineer, and started talking, and he really hated JCI, and JCI was saying, well, you have to do this and you have to do that. And well, no, I don't have to do that. And I mean, it was a big fight going on. So I went in there, and since I came from a hospital, he's a hospital manager, we talked the same language. And we went ahead and looked. For example, things don't make sense. They had these 100 horsepower secondary pumps with variable speed drives running at 60 hertz. Okay. The delta P at the end of the line was set for 40 pounds. Damn. These were all pneumatic valves. Pneumatic valves only can handle 20 delta P across the valve. So what was happening was all of the valves were being pushed open. You couldn't control the deck temperatures. The reheats were running like mad, reheating that cold air that was supposed to be at 55, 58 degrees. And it was completely out of control. So I said, well, let's move that down to about 18 psi at the end and see what happens. We did that, and we sat there at the computer watching it. The valves closed, the deck temperatures went up to set point because they were way below set point. The chillers started unloading, the boilers and the heating system started unloading, and things started coming in balance. And that's the whole thing about going in with an operational standpoint or view. So we went ahead and did that. And we did other things. We found all kinds of, wacky things that we needed to tune up. And then we started doing discharge air reset. We did hot water reset. We did variable drive reset. They were running like in the wintertime, 3 chillers to cool the place. And after we got finished, we were running 1 chiller. Okay. And it's just a matter of they were running chill water for flow, not the temperature. And when we closed the valves and did all that, we reduced the flow so we could provide cold water throughout the hospital with 1 chiller without overpumping the system. Okay. As a balance, but the first month I was there, they were billing 15,000. First month we billed, I think it was 23,000, and then the second month we billed over 31,000. Okay.
What's that? JCI billed the customer? That means, is that what you mean?
Pardon me?
The 31,000, the 15,000. That means JCI was billing the client.
Yes. Yes, this was a shared savings.
Oh, right.
I don't think anybody does shared savings now, but it was shared savings. We spent JCI's money to install this project, and then we had agreement for 10 years or something, and that's how we got our money back, by actually saving. Okay, and so we went up to $32,000, and it was positive ever since. Okay, and this again was an option C, because shared savings is an option C project. And that was an option C project that went wrong, okay, because they weren't operating it correctly. And most of my jobs, the 7 hospitals, when I was working in the branch that I had, I believe all of them were shared savings projects, and they were all positive. So going from there, then I was with JCI. I started gaining a little bit of reputation about making money on shared savings, because a lot of the shared savings projects weren't making money. So I started consulting, and then I started doing workshops. Okay, so probably the second year I was with JCI, I started doing workshops, and again we were looking at the operational point of view, and we started benchmarking more facilities. I started getting the utility information, from the people out in the field. They would send it to me and send me the savings, and then I would start benchmarking, and at a higher level. So let me go over here. And when we're talking about benchmarking, this is one of our worksheets that we had, and you can see we have all kinds of hospitals. So this is actually, looks like I have this sorted by region.
Hilarious.
Okay, so if we look here, we go by kWh per square foot. So in Alabama, it's about 36 kWh per square foot, and the target is 33 typically. And then we would look at kW, and we would look at the fuel, okay, MMBTUs per square foot, okay. And they were at, these were pretty high. This one here, we had a target of 77. So this is where we have high level benchmarking. Okay, we're just kind of comparing it to other facilities. But then down here, we actually, I'm looking for one. I actually started benchmarking projects like St. Elizabeth Hospital. This was the base year. This was year 1. Okay, so now I started gathering information on how low we can take these facilities. Now, St. Elizabeth Hospital was a problem. They were going to sue us because that was a option B project. Let me just talk a little bit about option A, B, and C. And this is my views on it and thoughts on it. These options are like insurance policies, okay? You can have a low deductible or a high deductible. High deductible, you have more risk, okay? Low deductible, the insurance company has more risk. So option A is a very high risk option for the customer. Option B is slightly less, but it still has a lot of risk for the customer. And option C has less risk for the customer, more for the ESCO. Okay, and this project was an option B project, and they did some work on the chillers. Actually, let me go back here, and this is the hospital right here. And so I think they had guarantee maybe of $200,000 a year, option B. They were only making 100,000. Okay, and the customer was ticked off because he's not seeing the reduction on his utility bill.
But they were showing it up with their option B. Is that was the problem? So Johnson was awarding 200,000.
Yeah, it was sold option B. Okay, it was sold as option B. Customer signed off on the option B. So you would think, well, customer, tough luck. We measured our chillers, we measured whatever efficiency that we needed to pick up, but you're not seeing that on the utility bill. You have problems, customer. You have some problems someplace. You need to get your act together and find your problems, because we're making our savings. Well, he said, well, BS on that. No, we've got to take you to court to sue you. Okay? Having unhappy customers is a problem. Okay? Because you're not going to get new work having unhappy customers. Mm-hmm. And so they called me up there, and what we did, we walked through the facility. One thing that is probably one of the most important tools in your tool case is an infrared gun. Now, this is an ancient infrared gun. It's probably 20 years old now, maybe more than that. But infrared guns, you really need to carry one with you all the time. But we went over there, and benchmarked it first. So first step was benchmarking to see where it was. And we benchmarked it both on the high level benchmark and something I haven't talked to you about yet, the more detailed model benchmark. Okay, so we went ahead and benchmarked it. The hospital was using about 33 kWh per square foot, 0.121 MMBTUs per square foot, which is high. Okay, we needed to get the hospital down to 30 and 0.1. So we walked through the facility, and I'm not going to go over all the things, but some of the gross things that were happening is they had 4 pumps with variable speed drives, I believe it was, but maybe it wasn't. But they had 2 primary pumps and 1 and 2 booster pumps. Well, all 4 pumps were running like mad. I mean, they were flowing water like mad. The chiller only had a 4-degree delta T across it, so it wasn't running very efficient, because it was like a 8-degree machine, I believe, delta T. And so I'm going, this isn't right. Something is wrong. So we walked the loop, and we found that the emergency chiller up in their part of the hospital up high at the very end of the loop, they ran at one time, and they left the valves open.
Oh, nice.
So there was water continually circulating through the chiller. They couldn't build any pressure. Let's turn off that valve, turned it off, and all of a sudden pressure started coming up, and things started working. Okay. We went through some of the air handlers again with the infrared gun. They had a surgery unit. They had a dedicated chiller on that surgery unit. It was 64, I think, degrees outside. We had to walk through the outside air to get to it. This was 100% outside air, if I remember right. And we walked through, and I go, it's hot. And I shot it, and it was like 98 degrees. It was 63 degrees outside, pouring 100% outside air in. The steam preheat was heating up to 90-some degrees, and then they were running the surgery chiller wide open, okay, just to cool it back down to 55 or 50 degrees or whatever they were trying to do. So let's fix this. Let's pretty, cool outside. It's not going to get cold. Let's turn off the steam. Turn off steam. Things bounced out. We checked a number of other air handlers. The preheats were either set incorrectly and or the valves were leaking. So we're paying a bunch of false load on the chillers, on the boilers, so forth. The boiler was running at 100 PSI. We needed to lower down the pressure a little bit because it was 125. I don't know. They had a laundry. They took the laundry out so we could lower the pressure, which we did. But remember, when you lower the pressure, you have to make sure that the steam traps can handle the lower pressure. Okay, because they're designed for 125 PSI, and you lower it down to 50, they may not work anymore. So there's operational stuff you have to look at there too. We wrote up a report about how to use chillers, the York chiller for surgery. We talked about that. The old chiller that was bypassing all the water. We talked about that. We had airflow issues in the cooling towers because of something, I forget what it was, but the air was recirculating. The cooling tower wasn't getting rid of the air, was sucking some of the air back down. Boiler pressure reduction. We did all that. We hot water reset. They were running the hot water hot all the time, and so we reset that. We turned off the surgery chiller because we could bypass the surgery chiller and put it on the main chiller. So we scheduled that, scheduled some air handlers, variable speed drives. We talked about installing some variable speed drives. This is a Coyote drive. I don't even know if they make them anymore, but it was a variable speed drive. It was a magnet in there that would slow down. The motor would stay the same RPM, but the output would slow down. That was a cheaper way of a variable speed drive back in those days. But at the end of this, okay, so I spent 8 hours maybe there with Mike Sims and a few other people walking through. I was doing kind of a class, and we walked through. The techs were walking with us. I gave them a list of what to do, programming, and I gave the list to the customer and what they needed to do on their side. But at the end, we were saving $300 a day or $100,000 per year. We made the savings, even though it was option D. The customer was happy and happy to recommend us that we really did care about them, to spend a few days there helping them out with their issues. They had no idea of these problems that they had, because a lot of times, you know, the engineering folks at the hospital or university or wherever aren't really, they don't know how HVAC works, okay? And a lot of times what I would have to do when I sequence chillers, I would type out the sequence of chillers, what temperature this chiller is supposed to be on, what temperature that, what pressures, and so forth. So I would type that out, because I had a problem if a chiller would turn off and it was getting warmer outside or humid outside or something. The doggone engineers would panic and they would go turn on their chiller. So I went ahead and I would write out the sequence. I would tell them, because I would do classes for them too on basic HVAC and how things were supposed to run, so they wouldn't mess me up, okay, turning stuff on and off. So I would write out, I would type out, and I'd instruct them, well, you know, these parameters are not met, you know, that chiller is supposed to be off. If those parameters are met, then it's supposed to be on. And if it's not on, call me. The other thing I did, I made all the customers read the utility meters every day and log them. And they would log them into the Johnson Controls computer, so I could remotely call up and see what was going on. Okay, because I knew how much energy the hospital was supposed to use per degree day for that given day. Okay, and so I could look and see if we were in balance or not. I had one project in Lafayette University Medical Center. I came there and they said, Greg, yesterday we used over 100 MCF of gas, okay? And we're always at 30 MCF. Something's wrong. And well, it was the day before, and then I got there that morning and said, well, for 2 days it's been doing that. Going, wow, we have something really wrong. We have a leaky steam trap. We have something going on. And so I went outside to get my infrared gun and some other tools. And I just looked at the stack of the boiler, and there was firing. Black smoke was coming out. This was a gas-fired unit. It was soot. And so I said, hey, something's wrong with your boiler there. Let's switch boilers. And we looked, and you know, there's a spring cam on the gas valve that you adjust with Allen screws to adjust the gas, because as it would full fire, you know, it would open up the valve and then it would start closing the valve on for the firing of the boiler. That spring broke. So the valve was wide open and it sooted up the whole boiler because it was burning too rich. And that's why they were using so much gas. So if they weren't reading the utilities every day, that would be a problem. And that's why you read utilities every day. That's what those old engineers at the aquarium were doing. They were doing it every shift, but they were looking for problems. They would never tell me.
So this is pretty much what you did at JCI's when there was problems. They would send you out on site and you'd take the M&V people with you and teach them as you went and diagnosed the buildings.
Yeah, I at JCI I did that. So I was kind of traveling around the country doing that. I was doing workshops around the United States. I did one in Europe and South America, China and stuff. And I was also tracking all of the M&V projects that we had and I guess the last few years at JCI, I switched off of the M&V into FPI, which was a software program we were developing. But up to that point, we had, I don't know, I think when I stopped tracking it and reporting shortfalls and all that, I think we had 5 billion, 6 billion of guarantees out there. And then it went up from there after I was doing something else. So I was
that wasn't 5 billion annually. That was 5 billion over the entire performance period.
That was the total risk that we had. So yeah, I remember when we got to 1 billion, going, oh yeah, it took us a long time, but after that it kind of snowballed. But now PC isn't what PC was. Back when I started and John started, we were on the cutting edge of it. Mm-hmm. And now there's a lot of people doing it. So it's no fun anymore. Not like it was back in the.
But they're not doing it like you did, or at least I don't think people are doing it like you did. It seems like what you did was you brought this retro commissioning component into M&V. That's really true. What you did. And see, to me, the hard part is, like you said, you have clients who don't like JCI or don't like your company, whoever it was, because they're not making savings and the reports say they are, et cetera, so they don't like you.
Yeah.
And you got to go in and convince them to give you the time of day, to listen to you, to assign someone to you to answer your questions and give you a day or 2 or 3 to go and look at everything. That's pretty tough.
Well, you know what? A lot of times, when we would do this, it was kind of fun because when we do this, talk to the director of engineering and tell them what I'm doing, and say, if you'd like to assign me a person or 2 or 3, I'll teach them. I'll show them what we're doing and finding issues. And a lot of times they would do that. I was in Mexico City one time, and we're looking at, what's a big oil company there? Starts with P.
Oh, Pemex.
Yeah, we were at Pemex headquarters. Okay. And I mean, I must have had like 10 people following me. Some of them spoke English, some of them did, but the ones that spoke English would translate to the air people. It was a lot of fun, okay, doing that. And usually the customers were happy to get the attention and happy to get some training.
And get the expert to come out. But the thing is, you were the expert. Some of these guys, so what I'm thinking of is I'm thinking of an M&V person, like some of the people who are attending here. They don't probably a lot of them don't know as much as you did. And everyone eventually has, problem buildings. And so you got to go out there and look at them and they're not really the expert. The problem. I mean, you brought that gravitas with you, but they might not have it.
Well, it's if you're just hiring engineers, okay, and you're doing contracting, and option D, or you're measuring a certain, you're measuring a certain number of items, and then you extrapolate that and so forth. And nowadays, from what I'm hearing, is people aren't even measuring anymore. And if we want to talk a little bit about measuring, let's see, where's that? Yeah, here. This is about measuring air handling. units, okay, you can measure air handling units to see how much airflow we're having by going in, and you need a kW meter, okay, for the fan to know what your kW is and your load factor or power factor. And then you also need one of these things, a manometer, okay? And if you take a reading across the fan and you know the kW, and I'm going to use load factor and power factor as the same. They're different, but they're close enough. And if you go into a program, and this was Market Manager, if I'm not mistaken. Yeah, this was Market Manager, which I really like Market Manager as a modeling program. I modeled a lot of buildings. I'm not smart enough to go ahead and calculate this the way a lot of y'all are, but I can use a modeling program to do all that heavy lifting for me. After Market Manager went away, I used eQuest. But if we go ahead and able to, and I'm looking here, if we can pin, let's see, maybe it's over here. Yeah, if we can enter the, that's outside there. I don't have an example of it, but if we can enter in the calculations, the delta P, the kW and power factor. It's been a long time since I've been through this. We can figure out what the airflow is, okay? And if the airflow is supposed to be 2,000 CFM, and it's 3,000, while you're overflowing the coil, you're not going to dehumidify and all that stuff. Or if you're at 1,000 CFM and the fan's running wide open, something's happening. You have a clogged up coil, you have clogged up filters, you have something going on. I was in Kansas City, I was at a convention center, and they hired a group to come out there and do all the measurements for the air handlers. So I said, I want to check these measurements because we're having some problems. I checked one air handler, and I mean, I opened up the door on the suction side, and the door just swung open. I'm going, there's no air. So I took my manometer and stuck it across the fan. I mean, that fan was sucking like mad. So when it's sucking real hard, it's not using the correct kW. Okay, it's using somewhat less kW, and there's no air, so there's no load, so the chiller's unloaded, and you're going to say you're going to save so much money by doing discharge air reset or whatever it is, when the air handler isn't consuming any energy.
Right.
Okay. I think the people who the air balancing people that took the readings, they were in the truck drinking beer and filling out the sheets or something. I don't know. But they didn't take readings. Okay. What happened was the filters were all clogged up and stuck into the coil. I mean, it was a huge mess. And I found that on a number of air handlers. So if you don't go out there and take readings and look at the equipment and make sure that the equipment is functioning reasonably correctly, you just got, the customer's not going to see the savings, and you're going to get a bad name, and it just causes all kinds of problems.
So this is, look, I don't know. I'm on the outside, and the people who are attending here are on the inside. They know what's going on in M&B.
Yeah.
But my impression is that there aren't enough people like you around. I'm not kissing your butt, by the way. But there aren't people like you, I guess, priced into these performance contracts. And I mean, that's part of the deal is you got to price the time and all that. But that M&V, or not M&V, but the retro commissioning portion just isn't done enough.
Well,
does it sound right?
I tell you, there are a lot of people out there that know how HVAC systems really work, not academically, but out there working. And because the systems aren't working the way they're designed after they are 5 years, 10 years old, because the maintenance people aren't maintaining them correctly. They're out there, if they get a cold call, they turn up the heat on the heating hot water. If they get a hot call, they turn the chiller down so it's colder, and all of a sudden everything's fighting. And you go ahead and take your infrared gun and you shoot a vent in one section of the hallway, and it's blowing out cold air, and you go over to the other end of the hallway, and that one's blowing out hot air, and you're going, well, it's two different air handling systems, and they're fighting each other, or the reheat's broken or something. There's problems there that we need to find out during the preliminary and detailed surveys. I had one more story. I had a hospital in, I think it was Beaumont, Texas, and I benchmarked it, and I'm going, they're not using enough energy. Something's wrong. They're environmentally sick, not energy sick. Energy sick when you're using way too much energy. Environmentally sick. So, something's going on because they're not typical. And so we went in there and started looking. We went to surgery. They had all the outside air vents boarded up.
Right.
They had plywood over them, and went to other ones, and they had other ones closed or boarded up. I said, why are you doing it? Oh, well, we don't want to freeze any coils. And we told them what was going on. We rolled it up and gave it to them and said that we don't want to do work with them because we can't do a PC project because you're not using the correct amount of energy. And if you want the PC project, all that has to open up, and your energy bill will go up by X amount. And so you have to look at those type of things. And I'm sure that a lot of the people that are on this call are looking at a lot of this and some of it, but it's just a good reminder. You have to touch and look at systems to make sure they're running. That they're running, they're not unhealthy, and you have to benchmark a facility high level, and then do a modeling benchmark. And the modeling benchmark looks like this.
We're not going to have enough to go into this part, Greg, because we only have a couple minutes to go.
We only have a few more minutes.
I think we're going to have you back, if that's okay, but we can talk about that offline, because I'd like to learn about this as well. That's good. So I've looked through the questions. There's a lot of people that hadn't, that said hello, hadn't seen you for a while.
I'm still alive.
Hello.
I'm in Texas, and in the cold Texas, we had some water breaks and stuff like that. So
so anyway, I think we're done, Tyler. Hey, Greg, thank you. This was really good. This was real good.
No one had any questions on any of this?
A lot of folks, Marcus Lee, I'm not supposed to use people's name. Sorry, Marcus. Marcus is nice to meet you. and Shankar Ernie also said the same thing. But no one asked questions. So there you go.
Anybody
Sometimes
have
that's
any
a good thing.
comment?
That means that you did such a great presentation. There was no need for questions, but most of the people
Or
just
everybody fell asleep. I thought
I
that was
know.
full of it. I don't
But
know.
I didn't fall asleep, so I don't think they did. So sometimes I do, but no. I don't think this was a snoozer. I think this was pretty good.